I'm on problem number 50. You can ask a question. There's too much buzz. It won't fit. Problem number 50 on page 128. Agricultural scientists are working on developing an improved variety of Roma tomatoes. Marketing research indicates that customers are likely to bypass Romas that weigh less than 70 grams. So 70 grams is something in this problem. The current variety of Roma plants produces fruit that averages 74 grams. Okay, 74 grams is our average right now, so that's our Y bar. It says it averages 74 grams. But 11% of the tomatoes are too small. It is reasonable to assume that the normal model applies. This is an easier problem. What? Okay, the normal model, okay? Normal model, average 74, right? I know 11% are too small, because it says customers are going to bypass those, right? They're too small. Well, somewhere over here, I'm not sure even what standard deviation is. This is 70 grams, and I know that from this point here is 11%. Yes? I just put it there. And see, they told me that customers are likely to bypass tomatoes at 70 grams. I'm sorry, guys, louder, Victoria, can hear you.
Why that location? Because 74 is right there.
Well, I know that 74 is my mean, and I know that 70 is less than 74. I'm not even drawing in my standard deviations yet. I might not even have to in this problem, because I know that 11% of the tomatoes are too small, and for a tomato to be too small, the problem is telling me 70 grams. Are we okay with that? Okay. Well, and I'm supposed to, the first question says, what is the standard deviation of the weights of the Romas now being grown? Okay. Well, what's my percentile at 70 grams? What's my percentile? I'm going to go inverse norm, 0.11. At 70 grams, I am at a negative 1.27 z-score. At 70 grams, I am in the 11th percentile. They told me that. They told me that. They said 11% of the people don't like it. And I'm going to get a z-score of negative 1.27. Okay with that? All right. So now I'm going to look at. You're right. Thank you. It is 1.23. I was looking at too many numbers. Negative 1.23. Z equals y minus y bar over s. This is an easy problem. This first part's easy, right? Z is negative 1.23 is equal to y, which is 70 grams, minus 74, which is our mean, divided by s. Now I just need to do the algebra. So I have s is equal to 70 minus 74 divided by negative 1.23. 70. Okay. All right, I'm sorry. I did this in my head too fast. I'm sorry. Let's go slower here. Okay. I'm going to multiply both sides by s. So I have negative 1.23s is equal to 70 minus 74. Is everybody okay with that? Now I'm going to divide both sides by negative 1.23. And I get s is equal to 70 minus 74 divided by negative 1.23. So I get negative 4 divided by negative 1.23. My standard deviation is equal to 3.25. That's the answer to part A. Yes, sir.
What exactly are we trying to find in this problem?
And this one, the first question was, what is the standard deviation of the weights of the Romas now being grown? Okay, and we just found it. Okay. So our initial normal model would be an N 74 3.25. That's what our model is right now. Yes.
From that, that's 74, so we'll go there to 30.
Yes. Yes. The normal model, we write it N mean standard deviation, or N Y bar standard deviation.